Oh, snaps. Why don't I have an unlimited Zoom yet? I still don't understand that. These nameless school peeps, they're not answering my inquiries about a unlimited Zoom. Let's see. Hey, Steve, can a brother get a unlimited Zoom, please?
So Nikki, Jade, Obeda, and I were working on the cookies problem right before this, and our Zoom cut out. We're
Yeah,
so
How'd that go?
I recorded it, so once it's done.
Okay.
Oh, nice.
Thank
doing
you,
it,
Nikki.
I'll
Sweet. Wow. Nice. Man, you guys don't even need me anymore. Like, what do you need me for? I'm just like the guy who like presses record. I don't. I'm replaceable like that.
No,
Dang.
we need your enthusiasm.
Dang, like I'm just the guy who pressed play. That's me, and then I just I tell bad jokes. That's about all I can do.
Also very motivational.
Yes, we need your motivation as well. Yeah, definitely. Keeping it real.
Keeping it real. Is that like when I turn my hat from like the front to the back? That's like keeping it real.
Yeah, definitely.
Unlimited Zoom access. All right. So what do we got today? So, all right. So for today's Zoom, I'm just going to be giving you guys the answers for the sprint. No, come on now. You guys know better than that. I wouldn't do that. Come on now. You guys wouldn't even want the answers. That's not you. That is not you. You know what? That's not you. You're just hungry, so you're not yourself. Go have a Snickers or something.
Can we actually get the answers though? But like tomorrow, just so we can see how they solved it.
I'll tell you what. I will do my best to help you. Like I've been helping you get the answers without telling you how to get the answers. And if you guys like anybody who finishes early, like I really hope that you get time to stretch, because it would be awesome if you guys got threes too, just for your own sake, right? It's a huge confidence boost. So we are missing.
I'm just hoping it takes me less than 10 hours. Less than 12 hours.
That was basically my goal every time.
I second that.
Joking. You guys think I'm joking, but I'm not. That's why I'm just the guy who pressed record. I think we're just missing Desiree. Yeah, Des, only person we're missing. So let's just get started right quick, DJ Quick. Let's start with 60 seconds of what breakthroughs did you have today? Hopefully it is about code or something related, but if it's not, we'll still celebrate it nonetheless. Let's start with Nikki.
I wasn't ready, but okay.
She wasn't ready. You want me to call on somebody else?
No.
Oh,
it's
okay,
fine. I guess my breakthrough would be like a one-on-one, just kind of like getting directions into certain things I'm confused about. And just getting comfortable with pair programming and kind of just picking a brain from everyone else. It's amazing. And, not so much of a lot of coding today, but just more kind of like picking brain and trying to see where I need to be tomorrow. That's pretty much what I've been doing today.
And Beach said that a few days ago. Do you guys remember? He said a lot of the time will be spent not coding. And actually, Obeda can attest to this, that, was it yesterday or the day before? He spent more time just thinking about the problem, how he wanted to approach it. So that's actually a good sign. Popcorn that. I see the little hand coming. Popcorn that.
Elise?
Okay, so my breakthrough for today was basically kind of a mental breakthrough. Just really practicing this poly steps and accepting, the struggle along the way. So, yeah. So, Obeda. Popcorn Obeda.
Guess mine were two breakthroughs. One was the yesterday thing. I think that really just changed my mind on recursion. When we did the restaurant, it really did blow my mind. I think my mind is still like grasping like what went down with the for loop and then the print and the the recursive nature of what we did. And then the second one was actually also in our one-on-one when we started talking about big O notation and arrays. That was like an eye opener. I'm like, yeah, I need to go read up on this stuff because I have like zero clue, and I should have focused during lecture today. So yeah, so those are my two big breakthroughs.
Do you want a white cheddar popcorn, somebody? You were muted the whole time there, Obeda. Muted.
Yeah, sorry, my laptop just keeps muting me. Yeah, I said I popcorn blue.
I knew it was gonna be me. Yeah, today I spent a lot of time manually writing out arrays for the cookie problem.
Sometimes you just got to do that, right? You just got to do that sometimes.
Yeah, just to see a pattern.
I did that too, Lou.
Good. Glad I'm not alone. Yeah, so I don't know. I didn't really have too much in the way of breakthroughs, but I'm still working on cookies. I had to stop because my kid was trying to eat a wall.
Your what's trying to eat a wall?
My child.
Oh, okay. Yeah, that's probably not. It's probably not that good.
Yeah.
Come on, Lorelai. All right, do you want to pick somebody, Louise?
Brian?
Breakthroughs. Yeah, no major breakthrough today. I'd say, if anything, like my kind of visualization of these recursion algorithms is improving, and like at least in my mind, be able to think like, okay, you start out with an array and then move things to another one until that one's empty. Yeah, so that's it's like slowly sinking in. So it's like a small win, I guess, in a long battle. As far as what I've been using to unblock, I don't know. One thing, like I hate the Python documentation site, and like I downloaded like the PDF of like the library, and so like if there's something like I want to look up like range, okay, what does that mean exactly? Or
yeah,
I don't know, like a pen or whatever. That I can like search a PDF for it. And I found it's I like it more than their website. So that was a breakthrough.
That's smart. That's smart. I would say another breakthrough is like you dress really nicely. You look like a country pop star or something. Like you pass for that with the beard and the plaid and stuff. So you want popcorn, somebody?
Yeah, Bolo. All right, popcorn. I don't think Tanya's on. I can't remember. No.
I have not. I had breakthroughs last night and today. Well, we were working with Obeda, and I got a better understanding of how to implement a cache, like the syntax, and that was very excellent because we're very nearly done with the eating cookies problem.
Awesome.
It sounds like someone just entered. Desiree.
That was Desiree. Desiree's in. Desiree, we're just going around 60 seconds and talk about, oh, it's okay. 60 seconds, any breakthroughs for today? That's it. And then popcorn, somebody.
So I had a breakthrough. Well, you helped me with my breakthrough with the that line on the recursive thing. I'm sorry, y'all. My fever is coming back, and I'm like feeling like I'm about to die. Turn that down. Sorry.
Des, can you repeat that? Can you repeat that one more time? Because like everybody here just thinks that I'm the guy who presses record on the Zoom. I just want to like let everybody know that I have some value in the group.
I don't believe it.
So I was saying that Tico helped me to go through to get a breakthrough on the recursive algorithm on the merge sort because I'm like way behind. But he definitely helped me have a breakthrough. So
How
I'm
much
almost
is he
done with
paying
that.
you?
Huh? How much is he paying me? Well, no. That's so funny. Like you're silent, and so what you're doing right now is hilarious. But I can't laugh. Stop making me laugh, y'all.
Wait,
Alright.
I thought laughter was the best medicine. Are you sick right now?
Yeah, and I am sick, but it hurts to laugh.
All right, let's popcorn somebody on that note.
I don't know who went so far. Catherine.
It's a really good guess.
Yeah. I'm good at guesses. That's why I play the horses all the time. Just playing.
Today I paired with a friend who I worked with in labs a lot, and we worked on the making change problem. And we put that in Python tutor to kind of like see how everything kind of like played out. So that was just like to help kind of figure out like initializing a cache with like the zeros thing for like the length, like which that pattern has been, that was in, I think in the merge sort one, like a bunch of, so like things are kind of like, I'm starting to like recognize things. So I think that's, yeah, the breakthrough. And then slowly wrapping my brain around recursion, though I fear to try. Yeah, so it was fine.
Okay, cool. Pick somebody.
Is there anyone left?
I think it's just me.
Just Jade.
Hey, hi.
Yeah. Hi. So can I just say, Catherine, the visualization is a big help. Like it helps to see where everything is going and how it runs through it. So thank you for that. Breakthrough, working with Tani Nobeta on the eating cookies was helpful to kind of see how far I need to go or what I need to work on so I can visualize like understanding and then planning. Like understanding is getting there, but it's really just once I understand, okay, how do we move on to planning? So that was very helpful. That was kind of like my breakthrough today.
Very nice, very nice. I'm gonna drop a link for, actually it's the same link that Catherine dropped yesterday. So maybe we can just pin that one and then people will be more likely to use it and may lead to more breakthroughs, more light bulbs. I should just be an electrician. My breakthrough yesterday was working on a Project Euler problem. It was find the sum of all the prime numbers below 2 million. And I wrote the code and I did exactly what I didn't, against what I preach, which is like, don't look for the optimal solution, look for the first pass solution, the dumb one, the slow one, the idiotic one. But I kept just saying like, I could just use a cache right now. And then like it was late, tired, I couldn't get the cache working. I'm getting all frustrated, gonna pull my hair out. And then I could just hear Tani like telling me to like tell her to like slow down, because one thing she does is she'll always like get ahead of herself, and it's like I do that all the time. So I just was hearing my own voice going, slow down. So I ran the code and it was really, really, really slow. Actually, I timed it and it came out to 3 hours and 11 minutes when I woke up this morning on the couch. So I need to optimize that. But hey, at least I have an answer for all the numbers that are below 2 million, the sum of them. So, all right. Like I promised you today, we're gonna go over some major things that you should be aware of for this sprint, but I'm not going to give you answers. I'm just going to like tiptoe like around the answer as close as I can for you, like legally speaking. So let's see. Go ahead and throw out some ideas out there. What do you think is going to be on there tomorrow? And I will answer yes or no.
Recursion.
How did you guess? Okay, yeah, that is on there. Regarding recursion, I would say understand what it is, like in theory. Like, what is it? Can somebody answer that question real quick? This is all recorded, so this is going to be great, like, review material for you. What is recursion? Anybody?
When a function calls itself inside itself.
That's what it's doing. Okay. What, like, when would be a great time to use recursion?
Permutations.
When you need to break something down to its smallest, simplest form.
Very good. Very good. Yeah. So like if you have a problem that has like, that needs to somehow get the sum of some smaller problems, then that's when you use recursion, right? So like the power, like anything to the power of n or whatever, like those are great opportunities to use recursion because you're able to call that function on itself. Let's see. What are some other topics you think might be on this sprint challenge?
Big O, the operations.
Yes. Yes. So not only do you have to know what big O is, looks like you're going to have to be able to apply it. Yeah. So this looks like something that you would do in an interview, which in an interview, they'll give you a code challenge. You solve the interview, or sorry, ultimately you solve the interview. You solve the problem and you're walking them through it with your polyas verbally, and then you implement your code in front of them, and then they're going to ask you like, what is the big O of this function, of your algorithm that you made for this? Like, what's the runtime complexity? What's the space complexity? Can anybody tell me what big O is? Big O notation? Anybody? What is big O notation?
Can you say that again?
What is big O notation? Try not to overcomplicate it. Just like, give me a ballpark idea. Just throw out some ideas that might help other people.
How something scales.
Yes, right. We should all think scalability whenever you hear the words big O notation. And it's also, you can also think of it like a language that allows two people to talk about how well something scales, right? So obviously like English is the language that allows me and Nikki to talk about Nyla, right? So like big O notation is like English, but it allows us to talk about, instead of Nyla, it allows us to talk about like how well a function scales. What do we mean when we talk about scale? Can somebody dive into that a little bit deeper? Like how well something scales?
How well it moves.
Sorry.
How fast it runs when the inputs become larger and larger.
Very good, very good. Yes, Luis, right on the money with that one. So what he's saying is as n increases, so as your input increases, like what does that do to the number of processes or lines of code? Like what does that do to that number that you have to run? So let's just say, for instance, you have a really simple function called print number, and you pass in one parameter called num, right? As num gets bigger, right? Oh, I'm sorry. Inside the body of the function would just be one line of code that says print num, and you're just printing the number. So what would happen if I increase the size of n? Let's go, Bryant. What would happen if I increase the size of n that's being passed into that function? It's just a print.
Have it would
what happens to the number of lines of code that your function?
It would equal n, so it would equal to the changes in n. Are you saying? Sorry, did you say for?
Sorry. So like
are you inputting a number, or what are you passing in?
Yeah, I'm sorry. This is a little bit hard for me. I should probably share my screen. Then that way you would have an example.
If you're only passing in a number, you're only going to be running, it's going to be constant. But if you're doing an array or something that grows, then it'll be n.
Correct. Let me pull up a replit, and then that will make things a little bit easier. Let me share my screen.
Yeah, without a loop, it's going to be constant. Once you start looping, it's going to be larger.
All right. Here we go. Here we go. Here we go. You ready for this? That's not the actual thing. Hold on a second here. All right, computer. Oh, don't do what Tiny's computer did. Come on. Oh, there we go. Okay. Replit. All right. Let's. Okay. Here we go. Let's go to my REPLs. There's too much stuff up in my face. Give me some Python up in here. Okay. Study guide. Come on, computer, you're making me look bad. You gotta move faster than that. Come on now. Oh, there it goes, created. Okay. Okay, so let's say I have a function just called print num, and I'm passing an n to it, right? The only thing I have in here is print n, and then I'm just gonna call the function. Okay, so as, like if I pass in, let's say I pass in just 1, right? And then as that number gets bigger, so if this is 100, right? What big O is telling us is the total number of processes, like so inside the function, like this right here, what happens to this number as, I guess I did that wrong, sorry. Here we go. Okay, so what happens to the number of lines of code that my function has to execute while n continues to go upwards? Does it increase? Does it go down? Does it stay the same? Does it increase exponentially? Like what happens to that number?
Constant.
Okay.
Sorry, go ahead.
I just said it's constant.
Correct. So that would be big O of what runtime?
1.
That is correct. Okay, now we're gonna make it a little more complicated here for you smart folks out here. All right. So let's say I have a for loop in here, right? So for I in range, let's go n. Okay. So if I do that, what is the big O notation now, Bryant? Like what happens to what we're running as this number continues to go up?
I think it's n,
Why?
because the number of processes, there's one process per iteration.
That is correct. I award you 500 points to Gryffindor. Okay, so now if we put another for loop in here, wow, this is like getting meta-ish. All right, for j in range, and what is happening now up in this piece, Nikki? Nikki, can you tell me? Oh wait, do you want me to, I can pass in Nyla's name in here and it might be a little bit more understandable. Is that? Okay.
You can do
Nyla!
that. I'm on the phone right now. Can I come back real quick? Just
Yeah,
2 minutes.
okay, I got to change the variable back then if I go with Elise, like what is happening to the number of processes in this function as Nyla increases?
Okay, so since we're increasing with, we have 2 for loops, that would technically make it n squared, if I'm understanding properly.
That's correct. That is correct.
Yeah.
So let me put some comments in here for y'all's. So you have like big O of 1 runtime, right? Which is constant. And you can just imagine that number of processes stays the same as n increases. Then you have big O of n, and let's see if we can speed this up here. So this would be linear, like you said, number of processes increases at the same rate that n increases. So you can kind of think of that as like, remember like in 8th grade, you learn about y equals mx plus b. The slope is the m, and just that like stays the same. Okay, and then you have the big O of n squared, which is what Elise just said. This is called quadratic. I will give you guys this replit so you don't have to write it down. Just focus on the learning part. Number of processes. And by the way, tomorrow you will need to write an essay or two. So be prepared for that as well. Number of processes increases in an exponential, or like a quadratic, you could say, in a
Exponential?
yeah, it would be, I guess it would be exponential, yeah. An exponential rate compared to n. Okay. So those are like the main ones you need to be really aware of. If we did like a merge sort or like a binary search where you're like dividing like a total number of possible combinations or permutations each time, what would that be considered? Which runtime?
What was the question again?
What is the runtime of an object that, or a function where like you're doing something kind of like merge sort or like a binary search where you're dividing, you're continually like dividing things apart, right? So like let's say like yesterday, okay, Elise talked about having a group of teddy bears, okay? Like the first thing she does is she splits the array of teddy bears in half. Now you have two groups of teddy bears, right? So I had one process right there, right? I just sliced it in half. Now I got two groups of teddy bears. Now for the second loop or second iteration, what have you, I had to slice 2 times now, right? So the number of processes just went from 1 to 2. I just sliced 2 times. Now if I were to keep slicing, like that number is just going to increase exponentially, right? The number of processes that I have to do to keep up with like an ever increasing n. So what would the runtime of something like that be?
They go 2 to the n.
Like yeah, that would be right here. Logarithmic, right, or linear arithmetic. As the size of the input increases, the runtime or space used will grow at a slightly faster rate. The solution is usable not actually. Yeah, so it's this one right here. It is, yeah. Right here, 2 to the n. Right? Because the first one you do, like you'll split it, like 2 to the 0 would be 1, right? And then you do 2 to the 1 is 2, 2 to the 2 is 4, right? So you're like basically doubling the number of processes you have to do as n increases. So it shoots right up like that on that line. It would be good to really know this as best you can. Like just know what like sucks, or sorry, know what sucks, and then know what's really good, and try to figure out. Hi, sorry, I'm doing a study guide thing right now, so to play with you a little bit. Know this guide right here. This one, I wouldn't say focus on the names, like the logarithmic, linear arithmetic, as long as you know like the big O notation itself. That's a little bit more important. Okay, so that's big O. Let me stop sharing now. What else do you guys think is on there? This is all recorded, so you will be able to refer to it later.
Memoization.
Memoization is, can somebody describe what memoization is? First of all, can you spell it? Second of all, do you know what it is? Obeda. You want to phone a friend?
Moization, memoization.
M-E. It's spelled. It's memorization
But
without
he
the
was
R.
yeah, but he was muted before he started talking. You
Oh,
thought he
okay.
went straight for the M-O. Oh yeah, he's
I don't know, man.
Meization. That's essentially, I guess, how to save stuff when you are coding, so that way it can be faster.
that's correct. What an example of memorization? Cache. Yep. Yeah, not like cash money, but like CACHE. You guys want me to spell that for you? You got that part? Okay. So, what would be a great example or great time to use a cache? Can somebody?
When you're using recursion.
That's a good time to use it. When else? Like, what's a really noticeable pattern? Like a O of n squared pattern, maybe.
Be like nested for loops.
Yeah. So anytime you have nested for loops, you'll see this recurring pattern over and over and over again for your code challenges, for interviews. You just basically, you create a cache and you just use one for loop. So basically you're sacrificing space for better like runtime complexity, better efficiency with the speed, as which I'll do tonight because my one code takes 3 hours and 11 minutes to process the sum of all the numbers, prime numbers below 2 million. Okay, sorry, I'm talking kind of fast. Let's see. So as I mentioned earlier, you will be doing like a short answer, like an essay type question. So it will, can't tell you what it is, but let's maybe, can somebody share their screen? Let's go over one of the problems for today, and then we'll also practice going through it line by line in order to figure out the runtime complexity of it, because that will be super important for tomorrow. So can somebody please share their screen, their code? I think like a bunch of people finished the cookies one, but somebody didn't finish the cookies one. So maybe we could do that one. Okay. Or anybody, who's that was just sharing?
That was me, but it's the wrong.
Oh. Okay.
I have a lot of screens open. Let me see.
I'm really interested in how you guys solve the cookies one together.
Well, it's not quite complete, so that's kind of actually nice for us here.
Oh, okay, great. I can just integrate it right into my review session here. I feel like a
Can you
substitute
see
teacher.
My eating
Yep.
cookie screen.
Mm-hmm.
Okay. This is good news because we got right to the very end and ran out of time.
Oh, okay.
And Obeda helped us very, very heavily.
Okay. So let's start with Palya's. Like, how do you go about solving this bad boy?
Maybe they're not tabbed right, because it should be working. I'm pretty sure this is the solution.
So something's not iterable?
Doesn't like, oh, should this be none or 0?
Oh, brackets, curly brackets.
Excuse me.
Right around.
So I would, I took out the, I don't know. You can try with the none and we can see what happens.
It
I
doesn't.
just said that it was none type is not iterable.
Yeah.
It would be the curly brackets.
Oh, because it's a dictionary?
Yeah, exactly.
Yep. Very nice.
Boom.
Okay, cool. So we know how to do it now for everyone else who's Obeda was really good. He actually was drawing on our screen. He was using the
Annotation tool.
Yeah, to help, because we asked him to help us think like how, or help us plan. That's what we were stuck on, like figuring out.
Okay. Like you couldn't visualize the cookies? Like he had to help draw cookies on the screen for you?
Yeah, and he did different types like chocolate chip, oatmeal.
Like Chips Ahoy, Oreo.
Yeah, we got confused between the raisins and the chocolate chips though.
Oh, okay, I got you.
It was really not ideal.
Okay. So like, can you walk us through this, please, Miss Tani Keller?
Sure. So
Really fast overview here.
all right, 4 minutes. So basically, I'm going to go back to the README first then.
Okay.
So we're asked to make a function called eating cookies, and it
Mhm.
takes in a parameter of n, and n stands for the number of cookies that you're putting in. So you have one input, which is n,
Mhm.
number of cookies, and you're going to get one output because it asks you the number of possible ways he can eat all the cookies in the jar.
That sounds familiar.
Yeah, so you want Obeda pointed out there's one input, one output. And there are these many options of or this many ways to eat the cookies. So he can eat one cookie, he can eat 2 cookies, or 3 cookies.
I feel like I'm picking up what you're putting down right now. So this would be like rock, paper, scissors, shoe.
Yeah.
Okay. All right. Okay.
Yeah.
I feel like I got it now.
So we for our for understanding, we put in num cookies. We added the cache last, so we tried to solve it. We solved it without using cache, and then it was a problem for the bigger numbers.
Oh, yep.
So then we put cache in. But essentially, we said that this would be our base case. So whenever the amount of cookies is equal to 0, it's going to return 1.
Okay.
Value is part of our cache. So imagine that used to just say return 1 instead of value. So we then put in another. Sorry.
So wait, can you explain the rationale behind it? Like, can you relate it to cookies for me? Like, so if num cookies equals 0, like you're gonna return the value 1. Like, does that mean that I only have one way to eat a cookie? Like I can.
Yeah. So if you have no cookies, there's the only way to eat it is really to not eat it because.
Right. Okay.
So that's your option.
That makes sense.
So that's one option. You can't.
That's sad.
Eat nothing, so that's it. And then if you look here, if you actually it's on. So down here, I did what like.
What Luis was doing?
Yeah. My understanding. So.
That's good.
So if you have one cookie, there's only one way to eat it. You're obviously like it doesn't. If you can't have 0 first because you can't not eat it and then eat it. That's not
right.
Really. So
Possible.
You're always going to have an eating option. So if there's one cookie, there's one way to do it. You eat the cookie. If there are 2 cookies, there are 2 ways to do it. You can eat one cookie and then eat one more cookie, or you can eat two cookies all at once, and so on. But notice that none of my arrays are more than 3. The number never gets up to 4, 5, and so on.
Right.
That's because of this parameter here that says you can eat 0 cookies, 1 cookie, 2 cookies, or 3.
Okay.
So because there's one way to, that's not right, but there's one way to eat 0 cookies, which is to not eat them. We made that our base case because we return 1.
Got it.
Then we made an elif statement. So if you can't have negative cookies in theory, but so then we put in the statement that says if you have more than 0, obviously. So if you have, then we want to, it used to just say, we want to return this recursive statement. So we're calling our eating cookies function. And then we're passing in the number of cookies. But notice that we're passing in 1 because each time you eat a cookie, then each time you eat a cookie, there's 1 less.
You got 1 less.
And then the second time you're going to have 2 less, or whatever it is, the number of increase. And then we realized that we were having a never-ending loop because we didn't specify what to do if we had a negative number passed in or negative value. So we made this statement and we just said, okay, if you have anything that's less than 0, just return 0. instead of like continuing through.
Perfect. Awesome.
And yeah, and
That's
then we
good.
pass.
Okay. This